Let's move on to the next question here. Question number 24. The equation of a rectangular hyperbola is 2x square plus 3xy minus 2y square minus 6x plus 13y minus 36 is equal to 0. If one of its asymptotes is x plus 2y minus 5 is equal to 0, then the other asymptote is, first option, 2x minus y plus 6 is equal to 0. Second option, 2x minus y minus 7 is equal to 0. Third option, 2x minus y plus 4 is equal to 0. Fourth option, 2x minus y minus 5 is equal to 0. The rectangular hyperbola is given to be with the equation 2x square plus 3xy minus 2y square minus 6x plus 13y minus 36 is equal to 0. Now this is a rectangular hyperbola given. By definition, in a rectangular hyperbola, the asymptotes are perpendicular to each other. So what are asymptotes here? This is a rectangular hyperbola. The asymptotes would actually be passing through the center of the hyperbola, and they will be rectangular. They will be making an angle 90 between them. So that is a rectangular hyperbola. So one of these asymptotes is given to be x plus 2y minus 5 is equal to 0. Maybe this is the one, x plus 2y minus 5 is equal to 0. Now the other one, what is that other one? We know that a line which is perpendicular to x plus 2y minus 5 equal to 0 can be written as 2x minus y plus some k equal to 0. Any line perpendicular to ax plus by plus c equal to 0 can be written as bx minus ay plus some k equal to 0. So we are using that 2x minus y plus k equal to 0. But then what else we know? It passes through the center of the hyperbola. Both these asymptotes will intersect at the center of the hyperbola. Okay, by the way, what are asymptotes? Asymptotes are the lines which are tangents at infinity. Okay, here now this 2x minus y plus k equal to 0 should be passing through the center of the hyperbola. What is the center of the hyperbola? If you call this as S, the second degree expression on the left hand side, if you call that as S, center is given by solving dou s by dou x equal to 0 and partial derivative of s with respect to y equal to 0. If you solve these two equations, we will get the center. What is dou s by dou x? That is the partial derivative of s with respect to x. That's going to be 4x plus 3y minus 6 is equal to 0. Dou s by dou x equal to 0. Similarly, dou s by dou y, what is that going to be? Minus 4y plus 3x plus 13 is equal to 0. Now solving these two, we will get the point of intersection. That is, that point of intersection will be the center of this hyperbola, and that center will be satisfied, will have to be satisfied by 2x minus y plus k equals to 0. So let's solve these two. What do we get here? We'll multiply the first equation with 3, second equation with 4 and subtract one from the other. So what do we have? 12x plus 9y minus 18 is equal to 0. Multiplying the first equation with 3. Second equation will let's multiply with 4. So what do we have? 12x minus 16y plus 52 is equal to 0. Now let us subtract one from the other. What do we get? We get 25y minus 18 minus 52. So that makes it minus 70 is equal to 0. So y is equal to 14 by 5. y is 14 by 5. Now what about the x coordinate here? We can substitute this here. 4x plus 3y is equal to 6, we know. So 4 into x plus 3 into 14 by 5. 14 by 5 is equal to 6. So 4x has to be equal to 6 minus 42 by 5. So that makes it minus 12 by 5. So x has to be equal to minus 3 by 5. X is minus 3 by 5, y is equal to 14 by 5. Now 2x minus y plus k equal, so what is that point? Minus 3 by 5 comma 14 by 5 has to be satisfied by this 2x minus y plus k equal to 0. So what is that k for which it will be satisfying it? Okay, now what is it? I'll substitute here 2 into minus 3 by 5 minus 14 by 5 plus k is equal to 0. So what is k? K has to be, this is minus 6 by 5 minus 14 by 5, k is minus 20 by 5, and that's equal to 4. So k is 4. So 2x minus y plus 4 equal to 0 is the other asymptote. So what is the other asymptote? 2x minus y plus 4 is equal to 0. So the right option is, option 3 is the right answer. Option 3 is the right answer. Let's move to the next question, number 25. If E and E1 are the eccentricities of the hyperbola, xy equal to c square and x square minus y square is equal to a square, e power 4 plus e1 power 4 is equal to, first option 9, second option 64, third option 8, fourth option 81. So let's move on to this question here. Xy equal to c square. This is a rectangular hyperbola. And a rectangular hyperbola has its eccentricity. This implies its eccentricity is root 2. Its eccentricity is equal to root 2. Similarly, x square minus y square equal to a square is also rectangular hyperbola. This is E is root 2. It's also rectangular hyperbola. These are two different forms of representation of a rectangular hyperbola. With a rotation of the coordinate axis, you can bring this xy equal to c square into this form and vice versa. Right. So this is a rectangular hyperbola as well, and its eccentricity E1 is equal to root 2. So e power 4 will be obviously root 2 power 4, and that is equal to 4. And E1 power 4 is also 4, and the sum has to be 8. So therefore the right option is option 3. Let's move on to the next question, question number 26. The equation modulus of under root of x minus 2 the whole square plus y minus 1 whole square minus under root of x plus 2 whole square plus y square modulus closed is equal to c will represent a hyperbola if c belongs to open interval 0 comma 6, second option c belongs to 0 comma 5, third option c belongs to open interval 0 comma root 17, fourth option c belongs to 0 comma root 19. Now modulus of PA minus PB equal to k, where k is less than AB, where P is a variable point, A and B are fixed points. Fixed points represents a hyperbola. This is a fact. That is, modulus of PA minus PB. P is a variable point. The locus of P said that modulus of PA minus PB is some constant K. With that constant, if it is less than AB, it represents a hyperbola. If the constant is K that is given is greater than AB, it's an empty locus. If modulus of PA minus PB is K and that K is equal to AB, then it is either a ray starting from A going away from B, or ray starting from B going away from A. Right. So here let us see if it has to become, now your P is x comma y. In the problem, A is 2 comma 1 and B is minus 2 comma 0 in the problem. What is PA? Distance PA, that is x minus 2 the whole square plus y minus 1 the whole square under root, which is what is the first expression. What about PB? X plus 2 whole square plus y square under root. Now modulus of PA minus PB is given to be some small c, and that's c. What is the length distance AB? Let's find out that. What is that going to be? Under root over 2 plus 2 the whole square, that is 4 square, plus 1 square. What is that? 16 plus 1, 17 under root 17. So your C should be less than, okay, now modulus, what we are given is, what are we given? Under root over modulus of under root over x minus 2 the whole square plus y minus 1 the whole square minus of under root over x plus 2 the whole square plus y square is equal to C. Instead of P here we have x comma y, and instead of A we have 2 comma 1, and instead of B we have minus 2 comma 0. So it is in the form of modulus of PA minus PB equal to some C. Instead of K we have C. So C should be less than AB. What is C? Therefore, for it to be representing a hyperbola, C should have been less than root 17. Okay. C by choice has to be a positive quantity because it has been equated to a modulus quantity. So that has to be positive. Therefore, C has to be greater than 0 and less than root 17. Therefore, this is the right option. Option 3 is the right answer. Option 3 is the right answer. Let's move to the next question. Question number 27. The center, one vertex and one focus of the hyperbola are 1 comma minus 1, 5 comma minus 1 and 6 comma minus 1. Its directrices are, first option 5x minus 21 equal to 0 comma 5x plus 11 equal to 0. Second option 5x plus 4 equal to 0 comma x plus 1 equal to 0. Third option 5x minus 7 equal to 0 comma 5x minus 19 equal to 0. Fourth option 5x minus 17 equal to 0 comma 5x minus 6 equals to 0. We are given that the center is 1 comma minus 1 and one vertex is 5 comma minus 1. Let's say A 5 comma minus 1, this is a vertex, and the focus is 6 comma minus 1. Yes, 6 comma minus 1. We observe that all of them are on the line y equal to minus 1. Okay. Now, we know that the distance from center to the focus is AE, and the distance from center to the vertex is A. Okay. Now the distance from center to the directrix, that is A by E. So what do we know? What is A for us? 4 units. Clearly, from center to the vertex we have Say this is the hyperbola. That's it. One branch of the hyperbola we have here. So distance from center to the vertex is, that's clearly A units, and that is 4, clear. 1 comma minus 1 to 5 comma minus 1, that's 4 units. And the distance from CS, this is CA, is 4 units. What about CS? That is AE, that is equal to 6 units. A is equal to 6 units. I'm sorry, 5 units there. It's 5 units. So this gives me E is equal to 5 by 4. So from here we have E to be equal to 5 by 4. So now what is A by E? A is 4 and A by E. What will be A by E? 4 divided by 5 by 4, that is 16 by 5. Okay. Now this directrix has to be x equal to some constant, because it has to be perpendicular to the line y equal to minus 1. And what is that constant? It has to be at a distance of, 16 by 5 units from the center. So let's add up that. Okay, now tell me, so 16 by 5 plus 1 should have been this coordinate. So this length is 16 by 5. So 16 by 5 plus 1 would have been the x coordinate of this point here. Okay, so that makes it 21 by 5. So 21 by 5. So x equal to 21 by 5 is one of the directrices. So 5x minus 21 is equal to 0 is one of the directrices. And similarly, from the center you'll have to move A by E units to the left also to write the other directrix. So 1 minus 16 by 5 will give me x equal to 1 minus 16 by 5 is another directrix we can have. What is that? 5 minus 16, that is minus 11 by 5, that is cross multiplying and bringing the terms to one side. We have 5x plus 11 equal to 0. So these two options are the directrices, and they are appearing in the first option. So option 1 is right, correct option. Let's move on to the next question, question number 28. The center of the hyperbola 3x minus 4y minus 12 the whole square by 225 minus 4x plus 3y minus 12 the whole square by 100 is equal to 1 is minus 84 by 25 comma 12 by 25. Second option 84 by 25 comma minus 12 by 25. Third option 84 by 25 comma 12 by 25. Fourth option minus 84 by 25 comma minus 12 by 25. Now 3x minus 4y minus 12 equal to 0, and 4x plus 3y minus 12 equal to 0. These two will become the transverse axis and the conjugate axis. Let's observe that these two are perpendicular. The slope of this is 3 by 4 and the slope of this is minus 4 by 3. They are perpendicular to each other. With a rotation of the axis, we can bring this into the form of some capital X square by A square minus capital Y square by B square equal to 1. So now what is the center of this? Obviously this is going to be identified as x and this is going to be identified as y. So when you solve these two equations, what you get is the center. So 3x minus 4y minus 12 is equal to 12 and 4x plus 3y equals to 12. Let us solve these two equations. So solving, we get the center, because one of them will be representing the transverse axis, other is the conjugate axis. The point of intersection of transverse axis and conjugate axis is the center of the hyperbola. So let's look for Okay, solving it. Multiply this equation with 4, multiply this equation with 3 and subtract one from the other. So what do we have here? 12x minus 16y is equal to 48, and here we have 12x plus 9y is equal to 36. Subtracting from one from the other, we get minus 25y is equal to minus 84. So minus 25y is equal to minus 84. That gives us y is equal to 84 by 25. 84 by 25. Now substitute that in one of these equations and get the value of x. So 3x minus 4y, 3x is equal to 12 plus 4y, and what do we have? Y is equal to 84 by 25. So y is equal 12 plus 4 into 84 by 25. Now solving these two equations, multiplying this equation, first equation with 4, multiplying the second equation with 3 and subtracting one from the other, what do we get? Minus 25y is equal to 48 minus 36, 12. That makes it y is equal to 12 by 25. Minus 12 by 25. Minus 12 by 25. Now let's use that value of y here. 12 plus 4y, 3x is equal to 12 plus 4y, and that is 12 plus minus 48 by 25. Okay, so that makes it, in fact we can cancel out 3 and we have x to be 4 minus 16 by 25. Okay, so that makes it here x is equal to 100 minus 16, that is 84 by 25. So x is 84 by 25 and y coordinate is minus 12 by 25. So that is, so what we have here is the center has to be 84 by 25 comma minus 12 by 25, and that is appearing in the option 2. Option 2 is the right answer there. So let's move on to the next question. Question number 29. One focus of the hyperbola is 3, 0 and corresponding directrix is 4x minus 3y minus 3 equal to 0. If its eccentricity E is equal to 5 by 4, then one vertex is, first option 3 by 5, 11 by 5. Second option 11 by 5, 3 by 5. Third option 7 by 5, 4 by 5. Fourth option 4 by 5, 7 by 5. Now we are given that one focus is 3, 0 and its corresponding directrix is 4x minus 3y minus 3 equal to 0. Okay. Now, and also we are given that the eccentricity is equal to 3 by 4. So let's say we have this hyperbola like this. This is the transverse axis. Now this is the minor axis, conjugate axis, let us say. Okay. We know that this distance from center to this focus is JEE, and the distance from center to this point, let's call this as a Z point, that is the foot of the perpendicular from focus to the directrix. This length is JEE, A by E. So now the distance from 3, 0 to this, and we know that this distance is from the center to A, the vertex is A units. So A units here. We know that the distance from center to the focus is AE, and the distance from center to the vertex A is A units. So AS has to be equal to CS minus CA. What is that? What is CS? AE. So we'll take A common. That's going to be E minus 1. A into E minus 1. But what is this? What is our E? 5 by 4. So that's going to be A by 4. So your AS is CS minus CA, and that is equal to A by 4. What about this Z, AZ? How do I get AZ? AZ is nothing but CA minus CZ. CA minus CZ. What is your CA? A minus CZ. What is CZ? A by E. So A into 1 minus 1 by E. That makes it A by 5. Because 1 by E is equal to 5 by 4. So 1 by E will be equal to 4 by 5. So 1 minus 4 by 5, that makes it 1 by 5 there, A by 5. Now I can say that we have therefore the segment Z, A, yes, if you look at this part, ZA, if it is A by 5, ZA is A by 5 and AS is A by 4. It means that A divides ZS, therefore A divides the vertex A, this is the vertex A, vertex A divides ZS internally in the ratio 4:5. 1 by 5 is to 1 by 4, that makes it 4:5. So I need to find out this point A. But to find that point A, what we'll do is, we will find out the point Z first. What is that Z? The foot of the perpendicular from focus to the directrix. Either I can directly use the foot of the perpendicular formula, or I write the transverse axis. How do we write the transverse axis? Transverse axis is perpendicular to the directrix. This is the directrix. And it has to be passing through 3, 0. So how do you write a line perpendicular to this? It is in the form of 3x and it is passing through 3, 0. So it should have been 3 into x minus 3 plus 4 into y minus 0 is equal to 0. That must have been our transverse axis. This is the transverse axis. So what is the transverse axis? 3x plus 4y is equal to 9. Solving that transverse axis and the directrix, this is the transverse axis, the directrix. If you solve these two, what is that? 4x minus 3y is equal to 3. Solving these two, solving this, we get Z point. Z point can be obtained solving these two. Now having found Z point, and since we already know the S, we have to find out A. A divides ZS in the ratio 4:5. So we will do that now. What do? We'll have to multiply the first equation with 4, second equation with 3 and subtract from the other. So 12x cancels and 16y minus of minus 9. So 25y is equal to 4 into 9, 36, 3 into 3, 9, 36 minus 9. So what do we have? 27 there. Okay, so y is equal to 27 by 25. 27 by 25. What about the x coordinate? X coordinate can be obtained by substituting the y value here. So 3x is equal to 9 minus 4y. So that makes it x is equal to 9 minus 4y by 3. So 9 minus 108 by 25 by 3. Okay. That makes it actually 3 minus 36 by 25. So that is 75 minus 36. How much is it? $39 by 25. So that's 39 by 25. So y is 27 by 25. X is 39 by 25. So the coordinates of this are, the coordinates of z are 39 by 25 comma 27 by 25. So we got the z point to be 39 by 25 comma 27 by 25. We know that A divides Zs in the ratio 4:5. So we use the section formula. The section formula goes this way. So 4 times of S is 3 comma 0, Z is your 39 by 25 comma 27 by 25. So 4 into 3, A coordinates we are writing here, 4 into 3 plus 5 into 39 by 25, that will make it by 4 plus 5 comma 4 into 0 plus 5 into 27 by 25 by 9. So that's clear. Now what do we have here? 39 5. So 4 into 3 12, 12 plus 12 into 5 60, 60 plus 39 99 by 9. So that makes it 99 by 5 by 9. So that makes it 11 by 5 here, comma, and we have here 3 by 5. 27 by 5 divided by 9, that is 3 by 5. So 11 by 5 comma 3 by 5 is one of the vertices. So the key point lies here. We observe that we actually found out the z point first. What was the z point? The point of intersection of the transverse axis and the directrix. And we made use of the fact that z A, the vertex, divides Zs in the ratio 4:5. And how did we arrive at it? That we have used the distances here from CS. We calculated the CA distance, then we calculated CZ distance, AZ and AS distances, and we found them to be in the ratio of 4:5. So the right option is option 2 is the right option. Let's move to the next question, question number 30. If the line ax plus by plus c equal to 0 is a normal to the hyperbola xy equal to 1, then A is positive, B is negative, first option. Both A and B are positive, the second option. A and B are both negative, third option. And the fourth option, A equal to 0, comma B is equal to 0. Now, ax plus by plus c is equal to 0 is given to be normal. This is normal. Now, what is the slope of the normal? Slope is minus a by b. It's normal to which curve? Xy equal to 1. So dy by dx, y equal to 1 by x is the curve. Writing it y as a function of x. Now dy by dx will give the slope of the tangent at a point x comma y. So what is that? Minus 1 by x square. Minus 1 by dy by dx at a point will give us x square, which is always positive. Okay. So whatever may be the x value, it has to be positive. So slope of the normal to xy equal to 1 is always positive. So what should we have here? it means that minus a by b, if this has to be the normal, minus a by b has to be positive. So minus a by b has to be positive. That means a and b, a by b must be negative. So a and b must be of opposite sign. This implies a and b are of opposite sign. So that is appearing only in the option 1. Therefore, option 1 is the right answer. Let's move to the next question, question number 31. If the normal to the rectangular hyperbola xy equal to c square at the point T meets the curve again at a point T1, then T cube into T dash is equal to 1. Second option, T cube into T dash is equal to minus 1. Third option, T square into T dash is equal to minus 1. The fourth option, T into T dash is equal to minus 1. Let's move on to how to approach this problem here. Xy is equal to c square. A general point on it with a parameter t can be written as ct comma c by t. Is a point on the hyperbola. Is a general point. That is, you have the hyperbola xy equal to c square, whose graph goes like this. A general point on it is ct comma c by t. Now let's write the normal equation at this point. The normal at this point. Now let's write the normal equation at this point, ct comma c by t. How do we write it? We need to know the slope of the time. We need to find out the slope of the normal there. What is the slope of the normal at the point ct comma c by t? Minus 1 by dy by dx. Let's go for that. Y is equal to c square by x. That gives me dy by dx to be equal to minus c square by x square. Now this is the slope of tangent. What we want is minus 1 by dy by dx. That gives us x square by c square. But at what point we are interested in finding out such the slope? This is the slope of the normal. So that is slope of normal at the slope of the normal at ct comma c by t is equal to c square t square by c square. The slope of the normal at ct comma c by t is, so instead of x, let's write ct, that is c square t square by c square. That makes it t square. Now therefore the slope of the normal is t square there. Now what will be the equation of the normal now? Y minus c by t. I can use this point and the slope is t square. So y minus c by t is equal to t square into x minus ct. Now this normal is, he says it's meeting the hyperbola again at some point t1 or t dash. Now we wanted a relation between t and t dash here. Now let us see here, what are the coordinates of this point? ct dash comma c by t dash. I can write it like that. We can do one thing here. The slope of this normal can be calculated by using the 2-point formula y2 minus y1 by x2 minus x1, and we will equate that to t square, then get a relation between t and t dash. So here, instead of going by this method, we can as well equate the slope here. So t square is equal to ct minus c by ct1, c by t minus c by t1, that is y2 minus y1, t dash by ct minus ct dash. So that makes it, c is cancelled and we have t dash minus t by tt dash divided by 1 by t minus t dash. C is cancelled there. So what do we have? This again cancels and we have minus 1 by tt dash. That is t square is equal to minus 1 by tt dash. Therefore, we observe that t cube t dash plus 1 is equal to 0. So, t cube t dash is equal to minus 1, or in other words is equivalent to saying t cube into t dash is equal to minus 1, which is the option that is containing that. Option 2 is clearly containing that. Option 2 has that answer. Let's move to the next question, question number 32. If the circle x square plus y square equal to a square intersects the hyperbola xy equal to c square in 4 points P with the coordinates x1, y1, Q with the coordinates x2, y2, R with the coordinates x3, y3 and S with the coordinates x4, y4, then first option says x1 plus x2 plus x3 plus x4 is equal to 1. Second option, y1 plus y2 plus y3 plus y4 is equal to 1. The third option says x1 into x2 into x3 into x4 is equal to c square. Fourth option says y1 into y2 into y3 into y4 is equal to c power 4. X square plus y square equal to a square. And xy equal to c square. Let's solve this too. xy equal to c square is a rectangular hyperbola whose graph looks like this. X square plus y square equal to a square is a circle with the center as origin. So now this circle is meeting the hyperbola in 4 points. That's what is given to us. So this may be P, this is Q, and this is R, and this is some S. Okay, the situation is like this. Now let us solve this too. Y is equal to c square by x. Let's eliminate y. What do we get? X square plus y square is c power 4 by x square minus a square is equal to 0. I am writing y as c square by x and putting it here. I am solving for these two curves here, eliminating y. What are we getting here? X power 4 minus a square x square plus c power 4 is equal to 0. Now from here, let us say these coordinates are x1, the x coordinates of these are x1, x2, x3 and x4 here. The y coordinates are y1, y2, y3, y4. Okay, so very clearly x1, x2, x3, x4 would have been the roots of this equation, or roots of this equation. Okay, the roots of this equation, and hence what do you have? Product of all the roots is one product of the roots x1 into x2 into x3 into x4. We find that is equal to c power 4. You see the constant term divided by this one here. So I mean the third option doesn't appear to be correct. x1 plus x2 plus x3 plus x4 has to be 0. The coefficient of x cube is 0. Therefore, x1 plus x2 plus x3 plus x4 has to be 0 there. Now, what could have been the right option here? What we have is y1, y is equal to c square by x we know. So, y1 into y2 into y3 into y4 must have been c square into c square into c square into c square, the whole thing divided by c square by x1 is your y1, c square by x2 is your y2, c square by x3 is your y3 and c square by x4 is your y4. But what do you know about x1, x2, x3, x4? This is equal to c power 4, What do we have in the numerator? C power 8. C power 8 by C power 4, that makes it C power 4. Therefore, y1 into y2 into y3 into y4 is equal to C power 4. And therefore, the right option is option 4 is the right answer. Question number 33. A tangent to the auxiliary circle of the hyperbola x square by a square minus y square by b square equal to 1 intersects the hyperbola in the points P and Q. Then the locus of the midpoint PQ is, first option, x square by a square minus y square by b square is equal to a square into x square by a power 4 plus y square by b power 4. Second option, x square by a square plus y square by b square the whole square is equal to a power 4 into x square by a power 4 plus y square by b power 4. The third option, x square by a square minus y square by b square the whole square is equal to a power 4 into x square by a power 4 minus y square by b power 4. The fourth option, x square by a square plus y square by b square the whole square is equal to a square into x square by a power 4 minus y square by b power 4. So we have a hyperbola. Let me draw it like this. This is the x square by a square. Curve is x square by a square minus y square by b square is equal to 1. Taking the transverse axis as the diameter and concentric to this hyperbola, we draw a circle, that is the auxiliary circle. This is the auxiliary circle. Auxiliary circle equation is, this is a comma 0 and this is minus a comma 0. These are the two vertices. Taking the vertices as the end points of diameter, we draw a circle here, and this circle is the auxiliary circle. That's equation is x square plus y square is equal to a square. Okay. Now he says a tangent to this circle is meeting the hyperbola in 2 points P and Q. We want the locus of the midpoint of PQ, that is some R, let us say. R is the midpoint of PQ. So QR is equal to RP. R is the midpoint. Now let's start like this. We want the locus of R, so let's start like this. Let x1 comma y1 be the midpoint of PQ. Now can we write this R PQ equation using the midpoint of this PQ? It's a chord of it, and I know that I'm assuming that the midpoint is R. So we can use the equation, we can write the equation of PQ using the midpoint chord formula. So equation of PQ using midpoint chord formula. Point chord formula. What is the midpoint chord formula? That is S1 minus S11 is equal to 0. Okay. So what is S1? That is xx1 by a square minus yy1 by b square minus of x1 square by a square minus y1 square by b square is equal to 0. Actually minus 1, there will be a minus 1 here, a minus of minus 1 will make it plus 1, and plus 1 and that minus 1 will cancel. So I am only getting this equation. So this is S1 minus S11 equal to 0. So that is the equation of our PQ. But what sort of this, what is this line actually? PQ happens to be tangent to this circle. So let's use the tangency condition. That is a perpendicular distance from this center, that is origin, to this line must have been equal to the radius. So but PQ is tangent to the circle. X square plus y square is equal to a square. So perpendicular distance from origin to this line. What is the perpendicular distance from origin to this line? Mod c by under root over the coefficient of x square plus coefficient of y square here. So right. So what do we have? Perpendicular distance has to be equated to a tangency condition. A is the radius. Perpendicular distance from origin to this line will be modulus of x1 square by a square minus y1 square by b square by under root of x1 square by a square, that's a coefficient of x square, plus y1 square by b square, x1 square by a power 4 because the square of it, and y1 square by b power 4. This is our a. Now we'll square both sides. What do we have? x1 square by a square minus y1 square by b square, the whole square, is equal to a square into x1 square by a power 4 plus y1 square by b power 4. Okay. Now we wanted the locus of x1 comma y1. So what you need to do is replace x1 y1 by the general coordinates. What is that? So x square by a square minus y square by b square, the whole square, is equal to a square into x square by a power 4 plus y square by b power 4. So that is appearing in the option 1. So option 1 is correct.